You get a chair? Alright, alright. So it should be live. Well, I just started it. I don't know if it's Oh, no. There we go. Oh, it's on. It's a little delayed. Okay. So, a little delayed, but welcome to the first Filabot live event. Not really sure how to do live video. This is our first live video. Controlling it from my phone here, and I'll take it away. I wonder how the sound is. Probably not good. Okay, so we're not sure how the sound is, but this is our first Filabot live event. And what we are in the middle of our warehouse. We're looking at the machining area. We want to give you an insight to what we do, how we work, what we work on, and what we're really passionate about. The first thing we're going to go through is a demo of our extruders. Very quick overview. First step in extruding is the extruder. This is our Filabot EX2 extruder system. This is the system that takes pellets. Let's see if I can get a better shot. Takes pellets. We feed it into the hopper. Hopper's already full, so I don't know why I'm filling it up. System melts it, extrudes it, puts it over our Filabot air path, and that system is a fan system that cools the filament. And then from there, goes to our spooler unit, and here it's taking the filament and putting it on an empty spool. So that's our very basic overview. The material we're running today is ABSFR. That material is a flame retardant ABS, made for applications where there could potentially be flames and you don't want plastic to be burning. Now, Josh did point out that we want to make a point to note that this isn't flame resilient, but it's flame retardant. So once the flame source is removed, the flame will extinguish. It won't continue to burn. We do have a flame test to show you that. You want to try it out, Josh? Do you want me to hold it? Oh boy.
Hold the plate.
Okay, this one is. Oh, okay. It's over here. So this material is the normal ABS. So this is the ABS that does not have, doesn't have any flame retardant capabilities. So, let's see. Yeah, it's smoking real good. How long do we let it burn? That's gonna really stink. All right. Okay. So that's the flame. Glad the doors are somewhat open. All right, let's do the next one. So this one is our ABS flame retardant. Wow. It still stinks, and it's still smoking, but as you can see, it's not staying lit. Oh yeah, we have popcorn. Kevin's in the background building a, what are you building? A shelf for the printers. Okay, cool. Yeah, Kevin's doesn't like the set being in the middle of the office, but we told him he could work around it. He's making do. All right, so that was our normal ABS, this one, which burned and stayed lit after we removed the flame source. And then this is our flame retardant ABS that goes out once the flame source is removed. Cool. Do we have anything more to say about that? Am I still stuck on the... Okay, that's good, that's good. Okay, there'll be a delay there. Do we have anything else about flame retardant? Oh, it was certified by a FAA company, so we have FAA certifications on it, and a UL flame retardant rating. For more information, check that out on our website. I think that's pretty much it with flame. Yep. We provide it as filament and as pellets. So if you have one of our systems, you can use our system to make it, and you get the plus or minus 0.05 tolerance that you need for 3D printing. Okay. So another prop. Plastic of the week. Thought that sounded cool. This week we have a plastic from SK Chemicals. The name of that plastic is called LE200. LE200 is an engineering grade plastic. That's what they call it. Which mimics rubbers or other TPU materials. It's flexible and resilient. Has a shore hardness 40 or 45 or 55, excuse me. It's a shore D. Stays in that flexible state in a range of temperatures, good chemical resistance, and it has UV resistant on it as well. Nozzle temp for 3D printing is 220 to 240 C, and the bed temp is 50 to 60 C. This week we have extruded it into filaments from pellets, and let's see, I'll give you a little stretch test. So you can see it's kind of stretchy. It does elongate as I just pulled it out, but it's pretty flexible stuff. Josh, we did have to print slower with it. What was like 50 or 30 millimeters a second? I think that's okay. So you do have to print slower with these softer materials. But one test, we actually printed a little Gumby, which is flexible. Look at that. He is just going. So this is pretty cool material. We are excited about this, and we will have a quick post for our Filament Friday up tomorrow. Gotta make sure I do that now. Filament Friday. Can I have some popcorn? We have an audience with popcorn. Live audience. They're not very lively. I'm done with it. I should have got water. Okay. There's plastic of the week. Oh, there's print of the week too. Gumby is the print of the week. This little guy here. Highlighting. How close can we get Gumby to this camera? Highlighting the flexible properties of the LE200. Well, actually, that's pretty much everything I have on the list. Grinder. Oh, yes. So some other things we will do on our live channel is play with this guy. This guy is our large industrial grinder. This is used for taking failed prints, grinding them down, turning them into pellets, so that then it can be extruded on the Filabot system. That's what the grinder is. I could get some prints. Show you how loud it is. Let's do that. 1 second. So we should have had this prepared, but we didn't. We have some old fads, fidget spinners that we're gonna grind up. Some other random stuff I'm dropping. All right, let's try it. So, the grinder is really loud and it makes shavings like this. I'm kind of looking at the screen so I can make sure it's, as you can see, nice little grindings that we can take up or take out of the grinder and put it into our extruder system. So that's the grinder. We'll be definitely playing with that more. Which is exciting. Do we have any comments? I don't think we have anybody watching this. We have 2 people. Cool. Oh, those 2 people. We have 2 audience members who are watching it. So. We've got 2 live audience members watching the live stream. Yep. Sweet. Yep. Cool. We didn't promote it much. But that's because we had no clue what we were doing. We could just watch through the extruder. Yep. Cool. I'm gonna get some water. Oh yeah, we'll get it in there. That wall sounds like. Okay, let's see. Oh yeah. All right, going back in. Cool. Let's see if I can get my. Cool. So that's what the Filabot does. When I took a quick intermission. Makes filament from pellets, from a wide range of pellets. Spools the filament, traverses it very nicely on a spool. We're not ready to take that spool off yet. We'll probably let it fill up and then we'll take it off, and I'll show you how nicely our spooler system traverses the filament. And let's see if we can zoom in on Josh and see what he's doing. Does the audience have any questions? Any at all? Right now, you're the only 2 audience members. Of course she does. Okay, back to the systems. I'm not good at filming with this thing. It's kind of hard, tiny screen. Okay, I guess I could show you how and why our EX2 system is so special. Need a second to dig that stuff out. 1 second. Move the shop around. Ta-da! This is why our Filabot EX2 system is so special. We've designed this screw in-house. Kevin has. Maybe he should tell you about it. Hey Kevin! Yeah? You want to come tell us about this EX2 screw? He's gonna say no. Can you tell them, the 2 audience members, about our EX2 screw?
Is that the latest one?
This is the latest one.
Alright. Well, in plastic extrusion, you have to melt the plastic to extrude it.
Why?
And you do that mainly by shear heating it, also through conductive heat. But the screw is designed this way to create like a pressure within the system. So consider the plastic going around the screw. It gets tighter as it goes out towards the end. So you have like solid plastic here. It's little pellets, there's air in it. As it goes across the screw, the air kind of gets pushed back out. The pellets get smushed into a solid, it's called a solid bed. And as that goes around, well, as it gets pushed forward, the bed melts on the outsides where it's shearing like against the barrel and the screw. Yep. And you get basically a melt pool. And at the end, this metering section, it's called, the polymer is completely melted. And this is the section that creates pressure, flow pressure through the nozzle.
And this is the piece that makes the consistent pressure.
Yep.
Right. So we feed up here pellets, the raw pellets from the grinder, from new pellets, goes through, melts, pressurizes, squirts out the nozzle, goes through our air path, cools it down, onto our spooler system, into your 3D printer, and all over again if you wanted it to.
Yeah. So we've come up with this design mainly through testing.
A lot of testing.
A lot of testing, and it works pretty well for most plastics in general, but
there are some issues with it.
Yeah, so some polymers don't do as well just because they work better with different compressions, different pitches, different designs to the screw. This one works great with PLA and ABS,
Yep.
which are kind of higher shear rate, lower melt flow polymers.
Compared to like a PET.
PET is very viscous when it's melted.
Because
so
it's
it doesn't
designed
work as well
to
with the screw.
be blow molded.
Yep.
Okay.
So we're working on designs that work well with other polymers as well.
Nice.
So, yeah.
Nice. Shout out
That's a
to,
good
is it what, Tato Machine Shop?
Yep. They do a good job.
They do a good job with our screws. Cool. I think it's doing well. What do we have for time? 20 minutes? We have to make it last a half an hour. All right. Is it good?
Yeah.
It's real good. In a second, Josh, we're going to take that off, and I want to show how well the traverse mechanism does. Another thing I could talk about quickly. We're at like 20 minutes. Yeah. That's true. All right, I got a few more things to add. Behind our only two audience members right now who are in the room, we have a pallet of filament that we are donating to Printerbot's Adopt-A-Bot program. Got a whole bunch of filament, got some Filaflex and Tolman. We have some of our PLA in there that we used to sell. We no longer sell that wide range of filament on our website anymore. So we're donating it to the Adopt-A-Bot program. Brooke Drum over at Printerbot is working on that program. He's working on rolling it out, and we are super excited to be supporting the cause that he is pushing. Yeah, I think we're ready with the spool. I'll shut this down. Oh. Boy, I bet the audio just got a lot better. Boom. So, as you can see, this is spooled. Well, this filament was just spooled in front of your eyes. It was. From pellets into filament, into printable, oh, we dropped the popcorn. Into printable filament. And it does look like the traverse was a little fast on this. But this filament would come off this spool really well. And this is some flame retardant filament. We're not gonna light this stuff on fire. This is a good spool. Cool. Well, I think that concludes it for our first Filabot live video stream. Unless we have any questions, comments, or concerns.
Did you get a viewer?
Did we get anyone?
Yeah. Just 3 watching.
Ooh, am I? Okay, cool.
Hi.
Hi, one viewer. Let us know if you have any questions. And as always, if anybody else has questions after watching this video, please send us an email, give us a call, and we are totally and fully excited to help you out. Awesome.
People can call you live.
That would be cool. That would be cool.
Put the phone number at the bottom.
Yeah. We could have the phone like right here. All right, maybe we'll do that for the next time. But until next time, happy printing. I don't know how to stop it.